Very good morning to one and all. Myself, Mr. Mabudur Rahman, Assistant Professor in the Department of Food Engineering from Kekeva College of Food Technology, Nasik. Today, I will cover first law of thermodynamics. So, first slide, first law of thermodynamics. The first law of thermodynamics states that heat is a form of energy and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that heat energy cannot be created or destroyed. It can, however, be transferred from one location to another and converted to and from other form of energy. Thermodynamics, that is the branch of physics that deals with the relationships between heat and other form of energy. In particular, it describes how thermal energy is converted to and from other forms of energy and how it affects matter. The first law that the internal energy of system has to be equal to the work that is being one on the system plus or minus the heat that flows in or out of the system and any other work that is done on the system. So the first law of thermodynamics that is based on the law of conservation of energy which states that energy cannot be created or destroyed but can be transferred from one form to the another form. So is the statement of the first law of thermodynamics. So the change in internal energy of the system that is equal to the heat added to the system minus the work done by the system. So delta U that will be equal to Q minus W. It means what? The change in internal energy to the heat added to the system to work done by the system. So see here what is enthalpy. Enthalpy it is equal to what? U plus PV. This variable indicate that four quantities is called as our thermodynamic potential. So we can say that in thermodynamic potential, if we define that our enthalpy is what? So there are the internal energy and enthalpy that is our equal to U plus PV where P is our we can say that pressure and V is the volume and then our enthalpy that will be equal to U plus PV. So if we define that what is enthalpy, enthalpy is the property of thermodynamic system that is convenient state of function preferred in many measurement in chemical, biological and physical system at constant pressure. Okay, so Q is equal to delta U plus P into delta V. Since in this case Q that will be equal to what? Delta H. It is useful quantity for tracking chemical reaction. If a result of an exothermic reaction, some energy is released to a system and it has to show up in some measurable form in the terms of the state variables. An increase in the enthalpy H is equal to U plus PV. Now see here what is the system work. When work is done, okay, when work is done by a thermodynamic system, it is usually a gas, okay, that is doing the work. I think have you understood that according to this diagram you are seeing here that work done by the gas at constant pressure, it is what? The line from A to B, okay, A to B, it represent an expansion of gas at a constant pressure and the work done is the area under the curve. So it is one of the example of our system work. When work is done by a thermodynamic system, then it is usually gas that is doing the work and the work done by the gas at constant pressure, then work done that will be equal to P into delta V. For non-constant pressure, the work can be visualized as the area under the pressure volume and curve which represent the process is taking place, and the more general expression for work done that will be equal to what? P that W that will be equal to integration of P into dV. Limitation that is the what? V1 to V2. Okay, so the integral expression gives what? the exact area under the curve which is equal to work. Okay. I think have you understood the first law of thermodynamics? Okay, thank you.